Okay, so we are going to continue with this part. Reaction 2 needs to take place in the absence of water to prevent formation of compound C. This is a compound C. So it means if the water is present, then this compound would have formed. If C is present in the reaction mixture of reaction 3, a different compound, compound D, will also form. Compound D has two identical functional groups. The infrared spectrum of D shows strong absorption at 1100 centimeter inverse and 1720 centimeter inverse, but no absorption due to OH bond. Okay, use the data booklet to identify the functional group present in D. Okay, so they have given us the values and they have given us that which was not going to be present over there. So if you see reaction 3 first, in reaction 3, we have this compound, and instead this compound, if we have this compound over there, okay, so obviously instead of B we are going to get a different compound D because we have OH present over here. And then that they are saying that in that compound D, there is no absorption at OH bond, which means that this D does not have OH group. Is this understandable? Yes, if anybody have any doubt, kindly ask. Now, what else we have to do? We have to just look at the data booklet and figure out these values. Okay, here we have the infrared values. So, if you see, they are saying that there is a strong absorption at 1100 centimeter inverse. So, if you see that the 1100 ranges over here from 1040 to 1300, and which is due to carbon oxygen single bond, right? So I write it over here. Uh, that absorption at 1100 centimeter inverse is due to C single bond O. Then the next absorption is at 1720 centimeter inverse. So if you look at 1720, it ranges over here and it is due to C double bond O, 1720, right? So we may write that absorption at 1720 centimeter inverse is due to C double bond O. Is this understandable?
Yes, sir.
And further, there is no OH group over there. That's the third thing. So we can write, if there is no absorption of OH group, so no OH or COOH, because COOH also have an OH group in it. So are present in compound D. So as it's of 3 marks, so we covered all 3 points. Yes.
सर एल्डिहाइड भी तो प्रेजेंट नहीं होगा, तो हम एल्डिहाइड को भी लाइक मेंशन करेंगे या नहीं?
Aldehyde, there is no aldehyde in your initial compound as well. There is any aldehyde over here.
Oh, okay, sir.
Why we have mentioned these two? Because they have mentioned that there is no absorption due to OH bond. So that OH group is present in carboxylic acid as well as it is present in an alcohol as well, both. So that's why we have mentioned this point over there, because they have informed us that there is no absorption of OH over there. Is this clear to everyone?
सर अगर हम COOH मेंशन ना करें तो मार्क्स मिलेंगे या नहीं मिलेंगे?
No, it can be marked because you have to mention that there is no OH present in the compound. That's fine.
Okay, sir.
Okay, now C part. Some other reactions of C are shown. C is reacting with sodium carbonate. So with sodium carbonate, only this part of the compound C is going to react, because with sodium carbonate, carboxylic acid would react. Then the product would be the salt of carboxylic acid, which is that here, instead of OH, we have a ONA. Okay, is this understandable? That is a acid base reaction.
जी सर.
Okay, then here we are getting a compound F, and that compound F is with the SOCl2, which is suggesting that this compound have a diol. And if it have a diol, then this reaction must be a reduction reaction where we have used LiAlH4 in dry ether, and what it did, it reduces the carboxylic acid into an alcohol. This carboxylic acid part is converted into an alcohol. Is this clear to everyone? Now they are asking for the structure of E. So I have already drawn the structure of E. So I can repeat it over here. That OH over here, double bond O over here, and here ONA. Right? Then next part. Suggest why NaBH4 is not suitable reagent to make F from C. Explain your answer. So if you recall that it is a mild reducing agent, it is not strong enough to reduce carboxylic acid. It's a mild reducing agent. It is not strong enough to reduce carboxylic acid. So I can write that NaBH4 is not strong enough to reduce carboxylic acid. Now, construct an equation for the reaction of this with SOCl2 to form CH2Cl2. So, this reaction, if you recall, when we reacted with the SOCl2, if you recall that reaction with a simple alcohol, let me recall that reaction first. We are going to get RCl, sulfur dioxide gas, and sorry, it's not HCl, it's H2O. So here we have a two OH groups. So we got a compound having a two chloride substituted. So here we got SO2 and H2O. Here we need 2 moles of this to balance the equation. So here in a one molecule we have a two OH groups. Both the OH groups are turning into Cl. Is this clear? Yes. Just if anybody have any confusion, kindly ask. Explain why C is very soluble in water. So C being very soluble in water, if you see, it have a OH group and a carboxylic acid group. Both can form hydrogen bonds with water. So we can just write that C forms hydrogen bond with water, and that's why it is very
सर
soluble in water.
एल्डिहाइड हाइड्रोजन बॉन्डिंग कर सकता है ना?
Yes, aldehyde, water can form a hydrogen bond with an aldehyde. Okay, the thing is that when we talk about the aldehyde can form a hydrogen bond with the water molecules, but aldehyde cannot form a hydrogen bond with the other aldehydes. That is the difference between aldehyde and an alcohol and a carboxylic acid. Both carboxylic acid and alcohols can form hydrogen bond with carboxylic acids and alcohols as well, and with water as well. But when we talk about aldehyde and ketone, they form hydrogen bond with water molecules, but they do not form hydrogen bonds with ketone and aldehydes themselves. The molecules of aldehydes cannot form hydrogen bond with each other. In the same way, the molecules of ketone cannot form the hydrogen bond with each other, but they do form hydrogen bond with water. Okay. Okay. So here we have completed the paper. I have shared the new paper with you. So I'm just ending the meeting and going to start a new meeting in which we will be starting the new paper. Okay. So you all may join back.